All right, next up we have Yan Huang, who will talk about more efficient secure computation from garbled circuits.
This is a work collaborated with my advisor David Evans and Jonathan Katz and Lior Malka. Secure computation is extensively studied especially for the two-party case. A well-known system is fair play. A lot of people use it. It provides a good compiler that allows you to write a high-level program and compile it to circuits, and it's easy to develop new privacy-preserving applications. However, everything seems fine, especially except it's very slow, and it will sometimes it will crash because it uses too much memory to store the circuits. Based on these drawbacks, we developed a new approach to do secure two-party computation more scalable and faster than before. We applied this approach to several applications, existing applications, and here's our result. In an application-independent perspective, we can do billions of non-free gates, as opposed to previous work that can do only a few of them. In terms of performance, we can do the performance of evaluating number of non-free gates is about 10 microseconds on a regular desktop with not much memory. Here's some application-specific results. Like we compared our result with the sci-fi paper doing the Hamming distance. We are a lot better. The general is orders of magnitude faster. It seems that here for Hamming distance we are doing a lot better because we found that sci-fi is pushing a lot of work into a pre-processing phase. However, it turns out it can be amortized over run. We also applied our approach to AES, and it's also an order of magnitude faster. More surprisingly, we recently did the same thing with the private setting section, and it turns out it beats even a custom designed protocol based on asymmetrical operations. And from this graph, you can see we are losing the green ones are our work. It's based on a shuffle, compare, and no, it's based on a sort, shuffle, and sort, compare, and shuffle algorithm. We are only losing at the ultra short security level, which NIST people recommend not to use after 2011. Here's a brief overview of the framework. We're not using any compiler, but we're not burdening the programmer a lot. Because programmer can identify the security critical components and transfer them, transform the part of code into a library, into circuits. And we showed in our paper it's easier to transform these circuits into Java code and compile this to a generator and an evaluator. There's no interpreter work. And we even applied this framework on mobile phones because the way we do it using pipelining, we can run very efficient private setting intersection on your Android phones to do common contacts, find the common contacts on two phones. And here's the link, and if you have an Android phone, welcome to try it, and that's the talk. Thanks.